Determine the ratio in which the line formed by joining the points 6, 8 and -3, -2 divide the other line which is formed by joining the points 2, 3 and 4, -7. Let us begin. So here we'll start with 2 points. Let's say point A with coordinates 2, 3 and another point B with the coordinates 4, -5. So let's join the 2 points with the help of a straight line. Next, we'll consider another point C. Let's say C has the coordinates 6, 8 and then we have another point D with coordinates -3, -2. We're going to join point C and point D with another straight line. Now the line CD is dividing AB in a particular ratio. Let's call it divides it into ratio lambda is to 1 and they intersect each other at point E. Okay. Now, in order to find out the value of lambda here, what we'll do? We'll need the coordinates of point E. Okay, to find out the coordinate of point E, it's nothing but the intersection of the two lines AB and CD. Meaning, we will be needing to find out the equation of the two lines. And once we have those two equations, we can solve the two equations to get the coordinates of point E. So let's first find out the equation of each of the two lines. To find out the equation of the two lines, we will be using something known as the 2-point form of a line. So let's quickly recap what's the 2-point form of a line. So the 2-point form states that if we have 2 points x1, y1 and another point x2, y2 and through these 2 points a line passes, then the equation of the line will be given by y minus y1 equals to y2 minus y1 divided by x2 minus x1 and this will be multiplied to x minus x1. So let's use this 2-point form to find out the equation of the line CD. The equation of the line CD will be y minus y1. So we'll be choosing C as x1, y1 and the coordinate point of D as x2, y2. So let's substitute y1 with 8. This will be equals to, now we need y2 minus y1, so that's -2 minus 8 divided by x2 minus x1, so that's going to be -3 minus 6. So this gets multiplied to x minus x1, so x1 will be 6. That's the x coordinate of point C. So solving this equation, we get 10x minus 9y plus 12 equals to 0. We're going to label this as equation number 1. Next, what we'll do, we'll try to find out the equation of the line AB. So what we'll do, we'll assume that A corresponds to x1, y1 and let B correspond to x2, y2. Fine. So now we have y minus y1. So here y1 will be the y coordinate of point A, so that's 3. This will be equals to, now we need y2 minus y1. The y2 that's -5 minus y1, so that's 3. Divided by, we need x2 minus x1, so that's going to be 4 minus 2 whole multiplied to x minus x1, so x1 will be simply 2. When we solve this, we're going to get the equation of the line 4x plus y minus 11 equals to 0. So this is going to be the equation of line AB. So what we'll do, we'll try to solve equation 1 and equation 2 to get the value of x and y, and that's going to be the coordinate of point E, which is x, y. Okay, let's do that. So here what we'll do, we'll take equation number 1 and keep it as it is. So we have 10x minus 9y plus 12 equals to 0. Then we're going to take equation number 2 and multiply throughout with 9. So we have 9 times 4, that's 36 plus 9y minus 9 times 11, that's 99. This will be equals to 0. Add the two equations to get 46x. So here positive 9y, negative 9y cancels out and then we have 87 equals to 0. So we get the value of x. So x comes out to be 87 over 46. Now that we have the value of x, we can easily find out the value of y. So let's use equation number 2. That's much simpler. So here from equation number 2, if we isolate y, the y will be equals to 11 minus 4 times x, which means we have 11 minus 4 times 87 over 46, replacing x with its value and solving for y, y comes out to be equals to 79 over 23. So we have the value of x. So that means we have now successfully obtained the coordinate of the point E. So coordinate of E will be x value corresponds to 87 over 46 and the y value corresponds to 79 over 23. Now let's go to a figure. So now that we have the coordinate of point E and we have the coordinates of A and B and the ratio in which E divides A and B, we can use the internal section formula to find out the value of lambda. So here, coordinates of point E, that's already given as 87 over 46, 79 over 23. We obtained this value just now. However, we can use the internal section formula to define the coordinates of point E. All we have to do is take lambda and multiply it with B. 1 will get multiplied with A. Meaning, if we want to find out the x coordinate, we'll take lambda and multiply with the x coordinate of point B. That gives us 4 lambda. And add it to, we take 1 and multiply with the x coordinate of point A, which is 2. So we have 2. Divided by the sum of the ratios, so that lambda will get added to 1. So this will go in the denominator. For the y coordinate, we'll take lambda and multiply with the y coordinate of B. We get negative 5 lambda added to 1 times the y coordinate of point A. So that's simply 3 divided by lambda plus 1. Okay, now what we can do, we can equate them. So let's take the x coordinate, which is 4 lambda plus 2 divided by lambda plus 1 equals to 87 over 46. And then for the y coordinate, we have 3 minus 5 lambda divided by lambda plus 1. That will be equals to 79 over 23. Now we can solve either of the equation to get the value of lambda. So let's use this particular equation. So we'll have 46 multiplied to 4 lambda plus 2 equals to 87 multiplied to lambda plus 1. Now 46 times 4, that's going to give us 184. We have 184 lambda plus 46 times 2, that's going to be 92. That will be equals to 87 lambda plus 87. We have 184 lambda minus 87 lambda. This will be equals to 87 minus 92. Now 184 minus 87, that's going to be 97. So we have 97 lambda. That will be equals to 87 minus 92. That's negative 5. So solving for lambda, we get lambda equals to negative 5 over 97. Or if we take the ratio lambda is to 1, that's 5 is to 97. Now the negative symbol tells us that actually it's not an internal division, it's an external division. So that means we have to write here externally. So we finally obtained the ratio in which CD divides the line segment AB in the ratio 5 is to 97 externally.